Good morning and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want us to explain example 11 of Algebra 8. And we are seeing a situation whereby we are supposed to state which values, if any, must be excluded from the domain of this function. And in the slide that you have just seen before this example, you have seen that there are two situations whereby cannot be mathematically viable. For example, we cannot divide anything by 0. 0 cannot divide any number. Of course, if you divide any number by 0, or you can even try, take your calculator, have your 2 divided by 0, it is not possible. It is math error, meaning that mathematically it is actually infinity. At the same time, we are also told that we do not have square root of negative numbers. We do not have square root of negative numbers. So if we see a function that is having a square root, of course we should remember that we do not have square root of negative numbers. Incidentally, we have two situations whereby situation A, we have a function which is having 1 over x. And we know very well that a denominator can never be 0. So the first one is easy because we cannot just have x is not equals to 0. X cannot be equals to 0. It can be anything else, but x cannot be equals to 0. Graphically, you may have something like this, whereby if you if you have any number 1, let's say 1, divided by 1, when x is 1, you'll always have 1. But when x is so small, such that it is just next to 0, but not equals to 0, for example, 0.00001, 1 divided by 0.0001 is such a big number. Let's just see what we are saying. If we can have 1 divided by 0.001, this is 1,000. So when 1 is divided by a very small number, just next to 0 but not equals to 0, positive 0.001, it is such a big number. Y is going to be 1,000. And because we cannot reach 1,000 in this scale, then it's just coming from far. At the same time, if we divide, if x now, if we have 1 divided by a very big value of x, let's say even 10 or even 100, a very big value of x going this way, because x moves this way positively, 1 divided by, let's say, 100, we're going to have a 0.01, such a very small number, but not equals to 0. So you'll have a graph that looks like this one. This graph will never touch the x-axis, and this graph will never touch the y-axis. It is asymptotic at that particular point because along the y-axis, x is 0 and 1 divided by 0 is not defined. Along the x-axis, 1 divided by a very big number, value of x, will never be 0, but very close to 0. At the same time, when x is negative, it behaves the same way. For example, when x is -1, let's say -1, 1 divided by -1 is -1. When x is a very big negative number, divide by a very big negative number becomes a very small negative number. So we have a graph that looks like this again. Y-axis is asymptotic and the graph is again asymptotic along the x-axis. But the question is answered here. X cannot be 0. This is just an elaboration of what is going to happen in case you are plotting a graph. That is part A. Part B, we are dividing again, and our x is at the denominator. Again, we should know that x minus 2 is not allowed to be equals to 0 because we are dividing. So by extension, x is not supposed to be equals to positive 2. When this negative 2 crosses over to this side, it becomes positive 2. X is not allowed to be 2 because when x is 2, 2 minus 2 is 0 and 1 minus 0 is not defined again. Graphically, we can just come up with a graph here, and we know x is not supposed to be a 2, so we know the graph is going to be asymptotic along that line. Suppose x is such a big negative number, and let's say negative 10. We are just going to have 1 divided by negative 10 is going to be 1 divided by negative 10 is going to be negative 0.1. Y is negative, yes, but a very small value of y, negative 0.1. What about when x is 0 for this matter? And when x is 0, 0 minus 2 is minus 2. What would happen? 1 divided by negative 2, we have something like negative 0.5. So we have, this is negative 0.5, but from a very small, it is asymptotic this way. But again, when x is a 2, the graph is asymptotic there. When x is a 2, the graph is asymptotic along that line. Asymptote means the graph will never touch that line. When x is a very small number, which is when x is slightly greater than 2, let's say 2.1. 2.1 minus 2 is 0.1. So 1 divided by 0.1, you get 10. It is 10. When x is 2.1, 2.1 minus 2 is 0.1. It's such a big number, but again asymptotic along that line. So that is the graph you're going to experience, and it is asymptotic along the x-axis and along the line x is equals to, this is the line x is equals to 2. The graph is asymptotic along that line, and of course this is the line y is equals to 0, or rather the x-axis. This is the line y is equals to 0, or rather the x-axis. So you can see now, to answer that question, x cannot be equals to 2, and this is how the graph is going to look like. That is part B. Part A, x cannot be 0, and this is how the graph is going to look like. Thank you, and let us meet in the next video.